Okay, this is a problem I did on the board because it's a bit tricky. We're considering two relations, R1 and R2, on the set S, where R1 is the entire set of the cross product of S with itself, S squared, S cross S. And R2 is the empty relation. Remember that a relation is simply a subset of S cross S in this case. So it could be the whole set and it could be the empty set. Those are both subsets of S squared. And so to describe these relations in words, R1 is the universal relation. It contains all elements of S squared. R2 is the empty relation containing no elements. And if you look at the definitions of the four properties that we generally consider, reflexive, symmetric, transitive, and asymmetric, S squared, that is the universal relation, has three of the four, or has two of the four. No, three of the four. It's symmetric, it's reflexive, symmetric, and transitive, but it is not anti-symmetric. Anti-symmetric means that certain elements can't be in it. The other three refer to elements that must be in it, and since it's got everything, they all get satisfied. This isn't a formal proof, obviously. The empty relation is not reflexive because reflexive requires certain elements to be present. Symmetric, transitive, and anti-symmetric. I'm saying yes to all of those because they're all defined with a universally quantified if statement, saying if such and such elements are in the relation, then such and such elements, other elements, either are or aren't. But in every case, the premise of those if statements is never true. And we know that in an if-then statement, if the premise is false, then the if-then statement is true. And so I'm saying that the empty relation is symmetric, transitive, and anti-symmetric due to that fact of if-then statements. Okay, hope that helps. Hope that's clear.